Hello students, welcome to my new video on the concept of moment of couple, a crucial concept in understanding the mechanics of objects in equilibrium. Moment of couple is a fundamental concept that underlines many of engineering and physics principles we encounter in our daily life. In last video, we have learned about one important concept, and that was moment of force. Now today we will learn about the new concept moment of couple, which is actually related with the earlier concept, that concept moment of force, about which we have learned in previous video. Now let us start today's video. First of all, try to understand the meaning of couple in physics. What do you mean by couple? It's very simple. Two equal but opposite forces acting at two different points of a body forms a couple. Two equal and opposite forces. See this figure. Suppose this is the rod, that is a rigid rod, that is one body, and on this body there are two forces, vector F1 and vector F2, acting at two different points in opposite directions. This is called as couple. So for the formation of couple, the two forces must be acting on same body. See here, this is couple, two equal and opposite forces acting at two different points on same body. Therefore, two forces will form couple only when, number one, these two forces are acting on same body. That means if one force is acting on one body and second force is acting on another body, then it cannot be called as a couple. Number two, two forces must act at two different points. Two different points, like this figure. But suppose if the two forces are acting at the same point, like this, then this cannot be called as couple. Therefore, two forces must act on same body at two different points. Number three, the two forces must be opposite to each other. That means if one force is acting in downward direction, then second force must act in upward direction. These two forces should be opposite to each other. If they have same directions, like this, if the two forces are acting in same direction, then it cannot be called as couple. And fourth condition, the two forces should be equal in magnitude and opposite in direction. Two forces should be equal in magnitude. Therefore, if first force is 10 Newton, second force must also be 10 Newton. If first force is 10 Newton, second force is 20 Newton, then that cannot be called as couple. So this is couple. Examples of couple are, number one, to turn a car, driver applies a couple to the steering wheel. Couple means equal and opposite forces. While we drive a car, and when we want to turn a car, we apply a couple on steering wheel. On one hand, we apply a force in one direction, say in backward direction. Then by other hand, we apply a force in opposite direction, that means forward direction, due to which this steering wheel turns. Couple produces rotational motion. कपलमुळे रोटेशनल मोशन होते, म्हणजे वस्तू फिरते. नंबर टू, सेकंड एक्झाम्पल ऑफ couple is used to open or close a water tap. पाण्याचा नळ चालू किंवा बंद करण्यासाठी आपण कपलचा वापर करतो. बघा या ठिकाणी आपण जेव्हा हा नळ चालू किंवा बंद करतो तेव्हा दोन फिंगरनी आपण ह्या टॅप वरती दोन अपोजिट डायरेक्शनला फोर्स लावतो. See this second figure. How we use two fingers to turn water tap. Now third example of couple is used to tighten or loose the screw. See this figure. We use a screwdriver to tighten or to loose the screw. We apply two equal and opposite forces on a screwdriver. We apply force on the screwdriver in one direction with the help of thumb, and remaining fingers exert force on this screwdriver in opposite direction. So these two equal and opposite forces form a couple, and due to this couple, this screwdriver rotates, and in this way we can loose or tight the screw. Now moment of couple, the important concept. What is moment of couple? Try to understand. Moment of couple means the ability of a couple to produce rotational motion is called as moment of couple, which is also called as torque. Ability of a couple to produce rotational motion. Consider this figure. Suppose this is figure 1. Suppose this is a rigid rod, and we are applying two forces on this rigid rod. One force vector F1 at point A. We know force is a vector quantity. It has both magnitude as well as direction. Its magnitude is given by length of this arrow, while this arrowhead represents its direction. Second force is acting at point B, and that force is vector F2. Vector F1 and vector F2, they are equal but opposite in direction. Now moment of couple, the magnitude of moment of couple is equal to the product of one of the forces and perpendicular distance between them. Magnitude of one of the two forces. We know magnitude of both the forces is same. If first force is a 10 Newton, then second force is also 10 Newton. So you can take magnitude of any one force. Moment of couple is, magnitude of moment of couple is product of one of the two forces and perpendicular distance between these two forces. In this figure, this AB, this line is perpendicular to both of these forces F1 and F2. Therefore this AB is a perpendicular distance. Therefore moment of couple in this figure 1 is given by one of the two forces, magnitude of one of the two forces, that is F into AB. AB is perpendicular distance. We know here F1 is equal to F2 equal to F. Their magnitudes are same, but remember their directions are not same. Their directions are opposite. Here we have taken only magnitude. Magnitude of one force, you can take any one, they are same in magnitude, into perpendicular distance AB. Consider this second figure. Here the same body, but forces are acting. Again two forces are acting at two different points A and B, F1 and F2. They are again equal and opposite. Their magnitudes are equal and their directions are opposite. See here, direction of F1 is this, and direction of F2 is exactly opposite to direction of F1. Their magnitudes are same, their lengths are same, but these two forces are not perpendicular to this line. So you cannot take AB as a perpendicular distance between these two forces. So in this case, you will have to draw perpendicular distance between two forces. Draw this line AC. Now this line AC is perpendicular to this force F2. At the same time, this line AC is perpendicular to this force F1, because this line, dotted line, and this force F1, angle between these two is 90 degrees. Similarly, angle between this AC and this F1 is also 90 degrees. Therefore, this line AC is perpendicular. Therefore, in this case, torque will be given. In figure 2, torque will be given by the formula F into AC, not AB. In first figure, that torque is F into AB, because here in first figure AB is perpendicular distance, but in second figure AB is not perpendicular distance between these two forces. On the other hand, AC is perpendicular distance. Therefore in second figure torque is F into AC. So in this way we can determine moment of couple. Remember, just like moment of force, moment of couple is also vector quantity. Consider this rigid body. Suppose A and B are 2 points inside the body, and let this is the line joining these 2 points A and B, and R is the distance between these 2 points in the rigid body. Suppose there is a point C on the surface of the body where a force F1 is acting. This force F1 is a vector because it has both magnitude as well as direction. This arrowhead gives direction while this length gives magnitude. Join this line CB. So you can see this entire line BC, this vector F is perpendicular to this AB. Similarly, consider one more point D on the surface of the body. Again, suppose there is a force F2 acting at that point B in opposite direction. Opposite means this vector F2 is opposite to vector F1. Here in figure you can see vector F1 is upward while vector F2 is downward. Again, join this line AD and you will see that this force F2 is perpendicular to line AB. So both the forces vector F1 and vector F2 are perpendicular to AB. Now draw this vector from A to C. So this is vector now because it has direction, at the same time it has magnitude. Its length will give magnitude. This vector gives a position of C with respect to point A. Position point C is that point where force F1 is applied. Let us suppose that vector is vector R12. So R12 is a vector quantity. It gives the position of this point, second point, with respect to this first point. If A is first point, C is second point. So R12 is a position vector of C with respect to A. It is vector. Therefore, we have drawn arrow over the head of this letter R12. Similarly, now extend this line further, this vector AC further, and you will see that this force F makes an angle alpha here with this position vector R12. Similarly, draw perpendicular from point B at point D. This is also vector and it gives a position of point D with respect to B, and let us call that as vector R21. So here you will see this was vector R12. Here it is vector R21. They are equal in magnitude but opposite in directions. Their magnitudes are same and directions are opposite. Now extend this vector further, and this angle beta is angle between this line, means position vector R21, and this force F2. So here from this figure it is clear that this first force F1 makes angle alpha with this position vector R12, and this second force F2 makes angle beta with this position vector R21. Now from this figure we have seen the concept of moment of force. The moment of force due to this first force F1. Suppose this force F1 try to rotate this body about this point A. So this point A is a point that is the center of rotation, or the line passing through this point A perpendicular to this figure will be the axis of rotation. Now this force F1 will try to rotate this body in anti-clockwise direction like this. The force F1 काय करेल, C या ठिकाणी जे ऍक्ट होतं आणि ते फोर्स या बॉडीला असं अँटी क्लॉकवाईज डायरेक्शनला ह्या ए मधून जाणाऱ्या ॲक्सिस भोवती फिरवण्याचा प्रयत्न करेल. त्याचं मोमेंट ऑफ फोर्स असेल. मोमेंट ऑफ फोर्सची डेफिनेशन ती कन्सेप्ट आपण आधीच्या व्हिडिओमध्ये पाहिली. ते असेल वेक्टर टाऊ इक्वल टू दिस वेक्टर वेक्टर R12 क्रॉस वेक्टर F1. And similarly, that torque will be given by another formula. This force F2 will also try to rotate this body in a anti-clockwise direction but about point B, and that torque will be given by R21 because this position vector of D with respect to B is R21 and that force is F2. They are equal because here you will see their directions, their magnitudes of F1 and F2 are same, their directions are opposite, but both try to rotate body in anti-clockwise direction, and we know anti-clockwise moment of force is taken as positive. म्हणजे F1 सुद्धा काय करतं, ह्या बॉडीला अँटी क्लॉकवाईज डायरेक्शनला फिरवायचा प्रयत्न करतं आणि F2 सुद्धा ह्या बॉडीला अँटी क्लॉकवाईज डायरेक्शनला फिरवायचा प्रयत्न करतं. त्यामुळे दोन्ही पॉझिटिव्ह आहेत. R12 आणि R21 दोन्ही वेक्टर्स इक्वल आहेत, म्हणजे त्यांच्या मॅग्निट्यूड सेम आहेत, त्यांच्या डायरेक्शन्स अपोजिट आहेत आणि फोरच्या सुद्धा अपोजिट आहेत, पण मॅग्निट्यूड सेम आहेत. परंतु दोन्ही अँटी क्लॉकवाईज फिरवायचा प्रयत्न करतात, म्हणून दोन्ही पॉझिटिव्ह आपण घेतलेले आहेत. मॅग्निट्यूड्स फोर्स आणि ह्या दोन वेक्टरच्या सेम असल्यामुळे त्या मॅग्निट्यूड्स या ठिकाणी सेम आहे. सपोज दिस इज इक्वेशन नंबर 1. इन स्केलर फॉर्म वी कॅन राईट वेक्टर tau equal to R12 F1 sin alpha, because angle between R12 and F1, this R12 and this F1 is alpha, and therefore it will be sin alpha here. This is by the definition of vector product or cross product. कारण आपण वेक्टर प्रॉडक्ट बद्दल मॅथमॅटिकल मेथड्स या चॅप्टरमध्ये शिकलोय, त्याच्यावरून हा फॉर्म्युला आपल्याला मिळतो. सिमिलरली दिस क्रॉस प्रॉडक्ट that will be given by magnitude will be given by R21 into F2, magnitudes of these two vectors, into sin beta. Beta is angle between R21 and F2. This R21 and this F2, beta is angle between these two vectors. Suppose this is equation number 2. But in triangle ACB, consider this triangle ACB and triangle ABD, this ABD. Now if this angle is alpha, then this angle ACB will also be equal to alpha, because they are opposite angles and opposite angles are always equal. Similarly in this triangle ABD, if this angle is beta, then opposite angle which is ADB, that will be also equal to beta, because they are also opposite angles and opposite angles are also equal. And here we can write from trigonometry, but see here these angles are alpha and beta respectively. We can write sin alpha equal to this, sin alpha equal to opposite side means this R upon hypotenuse means R12, that is AB upon AC. AB is R, we are taking magnitudes only, and this AC is R12. As we have taken only magnitudes, we have not drawn arrow over the head of this letter. Similarly sin beta equal to, see this second triangle, sin beta equal to opposite side AB, this AB upon hypotenuse this BD. But this AB is R, so R here, and BD is R21, so R21 here. From this we get R equal to R12 sin alpha, and here also R equal to R21 sin beta. So here in this equation R12 sin alpha will be R, and here R21 sin beta will be also equal to R. Therefore equation 2 can be written as tau equal to R into F1 is equal to R into F2, equation number 3. So this formula gives moment of couple. Moment of couple is given by R. R means perpendicular distance between these two forces, because F1 and F2 they are vertical, R is horizontal. Therefore R is perpendicular to both of these vectors F1 and F2. Therefore R is perpendicular distance. This AB is perpendicular distance between these two forces F1 and F2, that R into F1 or R into F2. You can take any one vector, as their magnitudes are same. Therefore we can simply write, we know magnitude of vector F1 is equal to magnitude of vector F2, that is equal to F, say, then magnitude of torque will be given by, here in equation 3 you can write tau equal to R into F, here also R into F. So we get one single formula for torque, that is R into F. Thus this moment of couple or torque is product of this perpendicular distance between these two forces and magnitude of one force, because magnitudes of both the forces is same. In this way we have derived the formula for moment of couple. अशा प्रकारे आपण moment of couple चा formula derive केलेला आहे. Now how to find SI unit and dimensions of moment of couple. Now see this figure. We have seen moment of couple is product of one force and perpendicular distance. Now here this AB is not perpendicular distance. Perpendicular distance काढायचा असेल तर आपल्याला काय करावं लागेल? We will have to draw a line like this line which is perpendicular to this vector F2 as well as this vector F1, and suppose this point is C here, then from this figure you will get sin theta equal to AC upon this R, sin theta equal to AC upon R. From that you get AC equal to R sin theta. Therefore torque is equal to R F sin theta. हे कसं आलं तर बघा, या ठिकाणी आपण काय म्हटलंय, टॉर्कचे डेफिनेशन काय आहे तर वन फोर्स, दोन पैकी एक फोर्स आणि दोघांमधलं परपेंडिक्युलर डिस्टन्स. तर दोघांमधलं परपेंडिक्युलर डिस्टन्स या ठिकाणी काय आहे तर परपेंडिक्युलर डिस्टन्स आहे AC. परपेंडिक्युलर डिस्टन्स दोघांमधलं आहे AC, म्हणजे AC इंटू एफ अशा पद्धतीने आपल्याला मिळालं. परंतु ह्या ट्रायंगलवरून आपल्याला काय मिळतं, साइन थिटा इक्वल टू अपोजिट साइड AC अपॉन R. त्याच्यावरून आपल्याला AC इक्वल टू काय मिळतं तर R साइन थिटा. म्हणून ह्या ACच्या जागी हे जे AC आहे त्याच्या जागी लिहिलं आपण R साइन थिटा, म्हणजे हा टॉर्कचा फॉर्म्युला आपल्याला अशा पद्धतीने मिळाला. Now we can use this formula to find SI unit and dimensions of this moment of couple. Now see, SI unit of force is Newton and that of R is meter. Sin theta does not have unit. Sin theta ला युनिट नसतं, म्हणजे टॉर्कचं युनिट काय झालं तर न्यूटन मीटर, हे झालं न्यूटन मीटर. हाऊ टू फाइंड द डायमेन्शन्स? नाउ वी नो this force equal to mass into acceleration. See here, mass into acceleration. Therefore we get torque tau equal to R ma sin theta. Now SI unit of torque will be equal to SI unit of this R ma sin theta. Now we know SI unit of R is meter, that of mass is kilogram, and acceleration is meter per second square. Therefore we get SI unit of this moment of couple equal to kg meter square, because this meter into meter that becomes meter square, kg meter square per second square, and or we can write that kg meter raised to -2 second raised to -2. या ठिकाणी हे -2 चुकून झालं, ते ॲक्च्युअली त्या ठिकाणी +2 पाहिजे, कारण या ठिकाणी आपण हे मीटर स्क्वेअर ऑलरेडी न्यूमरेटरमध्ये, त्यामुळे ते या ठिकाणी तुम्हाला मायनस करायची गरज नाही. फक्त सेकंड स्क्वेअर जे डिनॉमिनेटरमध्ये होतं ते आता न्यूमरेटरमध्ये लिहिल्यामुळे ते तिथं मायनस झालेलं आहे. आता त्यावरून आपण डायमेन्शन्स कसे लिहिणार? डायमेन्शन्स ऑफ मोमेंट ऑफ कपल आर m1, बिकॉज m स्टँड्स फॉर मास अँड युनिट ऑफ मास इज kg. ते एकदा आलं म्हणून m⁻⁴. मी तुम्हाला आधी सांगितलंय बघा, या ठिकाणी हे जे आहे m⁻²+ आहे, आणि हे मीटर आहे जे लेंथचं युनिट असतं. इथं मीटर स्क्वेअर आहे म्हणजे मीटर दोनदा आलं म्हणून l⁻² घेतलं आपण, आणि सेकंड रेस्ट टू -2 कारण सेकंड हे टाईमचं युनिट आहे आणि सेकंड हे दोनदा आलेलं आहे आणि ते डिनॉमिनेटरमध्ये आहे म्हणून इथं सुद्धा आपण t⁻² घेतलं. तर अशा पद्धतीने आपण याचे डायमेन्शन्स काढतो. डायमेन्शन्स SI युनिट अँड डायमेन्शन्स ऑफ मोमेंट ऑफ कपल. साइन कन्व्हेन्शन्स ऑफ मोमेंट ऑफ कपल. मोमेंट ऑफ फोर्समध्ये सुद्धा आपण पाहिले की साइन कन्व्हेन्शन्स, तर इथं सुद्धा तशाच पद्धतीचे साइन कन्व्हेन्शन्स आहेत. व्हॉट आर साइन कन्व्हेन्शन्स? द मोमेंट ऑफ फोर्स, ॲक्च्युअली हिअर इट शुड बी मोमेंट ऑफ कपल. Moment of couple is positive if it produces rotation in anti-clockwise sense, and it is negative if it produces rotation in clockwise sense. That means if the moment of couple rotates the body, suppose this is the circle along which the body rotates, and if this moment of couple rotates the body in anti-clockwise direction, like this, anti-clockwise direction in this way. Then in this case, that moment of couple is taken as positive. हे moment of couple जे आहे ते पॉझिटिव्ह घेतलं जातं. On the other hand, if the moment of couple rotates the body in a clockwise direction like this, clockwise direction in this way, if moment of couple rotates the body in a clockwise direction, then that moment of couple is taken as negative. So these are the sign conventions for moment of couple. Now we will see the difference between moment of force and moment of couple. What is difference? In previous video we have learned about this moment of force, and in today's video we have seen the concept of this moment of couple. What is the difference between these two? Number one, moment of force is given by this formula, torque equal to vector r cross vector f, while in case of moment of couple, the formula for torque or moment of couple is vector r12 cross f1, that is equal to vector r21 cross f2. See these figures. In case of moment of force, a single force is acting on a body and that rotates the body about axis passing through some point, say E. In case of moment of couple, there are two forces like this, F1 and F2. Two forces are equal in magnitude and opposite in direction. So this is the first difference between moment of force and moment of couple. Now see the second difference. What is the second difference? Torque depends upon the axis of rotation and the point of application of the force. Here in case of moment of couple, torque depends upon the two forces. That is, it is independent of the axis of rotation or the points of applications of forces. See these figures. In case of moment of force, torque depends upon the axis of rotation. Here in this case, this force is acting at point C and this force rotates this body about this point E. Point E, axis of rotation passes through this point E. If the axis of rotation is changed, suppose we take another point here, somewhere here, and if we try to rotate that body about that axis of rotation, then this distance will change, or the perpendicular distance between that axis of rotation and that force will change, and magnitude of moment of force will change. But in this case, torque does not, this moment of couple does not depend upon the axis of rotation. Here in the second figure you can see these two forces, F1 and F2. This moment of couple depends on perpendicular distance between these two forces only. जोपर्यंत हे ए बी डिस्टन्स फिक्स आहे तोपर्यंत ॲक्सिस ऑफ रोटेशन मग तो ए मधून जाऊ द्या, बी मधून जाऊ द्या, किंवा मध्ये कुठेतरी पॉईंट घ्या तिथं असू द्या, किंवा एच्या डाव्या बाजूला इकडे असू द्या किंवा बीच्या उजव्या बाजूला इकडे असू द्या, कुठेही असला तरी ॲक्सिस ऑफ रोटेशनवर ते मोमेंट ऑफ कपल डिपेंड नसतं. आणि ते आपण याच व्हिडिओमध्ये थोड्या वेळानंतर यानंतर आपण प्रूव्ह करणार आहोत. Then the third difference. What is third difference? We have seen two points of differences between this moment of force and moment of couple. Now see the third difference. It can produce translational acceleration also if the axis of rotation is not fixed or if friction is not enough. In this case, but in case of moment of couple, does not produce any translational acceleration but produces only rotational or angular acceleration. म्हणजे या ठिकाणी कसं आहे की जर समजा हे फोर्स लावल्यानंतर ती वस्तू तर फिरणार आहेच, पण त्याच वेळी ती वस्तू एका जागेवरून दुसरीकडे पुढे जाऊ शकते. म्हणजे या ठिकाणी दोन्ही मोशन होऊ शकतात, रोटेशनल सुद्धा आणि ट्रान्सलेशनल सुद्धा. परंतु इथं मोमेंट ऑफ कपलमध्ये तसं घडत नाही. वस्तू एकाच जागेवर राहील आणि एका जागेवर फिरेल, एका जागेवरून दुसऱ्या जागी जाणार नाही, म्हणजे ट्रान्सलेशनल मोशन होणार नाही. नाउ व्हॉट इज द फोर्थ डिफरन्स? चौथा फरक काय आहे? It is its rotational effect can be balanced by a proper single force or by a proper couple. म्हणजे या ठिकाणी काय होतं की समजा आता आणि पहिल्यांदा इकडे बघा मोमेंट ऑफ कपल मध्ये काय म्हटलं, इट्स रोटेशनल इफेक्ट कॅन बी बॅलन्स ओनली बाय अनदर कपल ऑफ इक्वल अँड अपोजिट टॉर्क. इथं कसं आहे की समजा हे फोर्स जे आहे ते ह्या बॉडीला अँटी क्लॉकवाईज डायरेक्शनला फिरवतं, ते मोमेंट ऑफ फोर्स झालं. त्याला थांबवायचं असेल तर अपोजिट डायरेक्शनला तुम्ही फोर्स किंवा कपल लावून म्हणजे इक्वल आणि अपोजिट फोर्सेस लावून तुम्ही त्याला फिरवायचं थांबवू शकता. परंतु या ठिकाणी कसं आहे की इथं दोन फोर्सेस आहेत आणि दोन्ही सुद्धा त्या बॉडीला अँटी क्लॉकवाईज डायरेक्शनला फिरवतात. आता याचं रोटेशन थांबवायचं असेल तर तुम्हाला अपोजिट कपल लावावं लागेल. तुम्ही एक सिंगल फोर्स लावून ते थांबवू शकत नाही, तर तुम्हाला इक्वल आणि अपोजिट दोन फोर्सेस लावूनच ते थांबवावं लागेल. दिस वॉज द फोर्थ डिफरन्स. फायनली इन दिस व्हिडिओ we will prove that moment of couple is independent of axis of rotation. Consider this figure. This is a rigid body. Here there are two forces, vector F1 and vector F2, acting at two different points A and B. These two forces are equal in magnitude and opposite in direction. These two forces together will produce rotational motion of this body in anti-clockwise direction. या दोन फोर्सेसमुळे ही वस्तू अँटी क्लॉकवाईज डायरेक्शनला फिरेल. ह्या बी आणि ए या दोन पॉइंट मधलं हे अंतर आर आणि ते F1 म्हणजे हा पहिला फोर्स F1 आणि F2 ह्या दोघांमधलं परपेंडिक्युलर डिस्टन्स आहे. बिकॉज दिस लाईन BA is perpendicular to both of these two forces F1 and F2. Now moment of couple about point O. Suppose the axis of rotation passes through this point O. That axis of rotation is perpendicular to the plane of figure. या ठिकाणी axis of rotation जो आहे त्या फिगरला परपेंडिक्युलर आहे, त्यामुळे तो आपण या ठिकाणी दाखवलेला नाही. म्हणजे की अशा पद्धतीने हा axis of rotation इथे आहे परपेंडिक्युलर टू द प्लेन ऑफ फिगर. आणि हे फोर्स काय करणार आहे, आता पहिल्यांदा ओ पॉइंट मधून तो ॲक्सिस ऑफ रोटेशन जातो. दिस फोर्स F1 विल ट्राय टू रोटेट दिस एंटायर बॉडी अबाउट दिस ॲक्सिस ऑफ रोटेशन इन अँटी क्लॉकवाईज डायरेक्शन. या ठिकाणी काय होईल, हे फोर्स F1 जे आहे या बॉडीला अँटी क्लॉकवाईज डायरेक्शन असं फिरवायचा प्रयत्न करेल ओ भोवती, या ॲक्सिस भोवती. आणि हा पॉइंट बी काय करेल तर तो सुद्धा त्या बॉडीला ह्या पॉइंट भोवती ह्या ॲक्सिस भोवती तो अँटी क्लॉकवाईज नाही तर तो अशा पद्धतीने क्लॉकवाईज फिरवायचा प्रयत्न करेल. सिच्युएशन बघा, म्हणजे या ठिकाणी जी सिच्युएशन आहे त्याच्यानुसार पहिला फोर्स F1 त्या बॉडीला ओ या ॲक्सिस ऑफ रोटेशन भोवती अँटी क्लॉकवाईज फिरवायचा प्रयत्न करेल, तर F2 जे आहे ते क्लॉकवाईज फिरवायचा प्रयत्न करेल. आता आपण मगाशी पाहिलं की अँटी क्लॉकवाईज कपल असेल मोमेंट ऑफ कपल तर ते पॉझिटिव्ह आणि क्लॉकवाईज असेल तर ते निगेटिव्ह. आता पहिल्यांदा पहा, मोमेंट ऑफ कपल अबाउट O ड्यू टू F1 इज ड्यू टू दिस फोर्स F1 इज गिवन बाय, and that formula will be vector tau 1 equal to this OA cross vector OA, this vector OA, O to A, that is a vector, cross this force F1, that is equal to F into OA. That means in scalar form without considering directions, because this OA is perpendicular to this F1 and we know sin 90 is 1, therefore we can write tau equal to F into OA, and this will rotate that body about an axis passing through O in anti-clockwise direction. So in anti-clockwise direction, moment of couple about O due to F2, now due to this second force, is given by vector tau equal to vector OB, because we have to take this OB distance now, distance between this axis of rotation and the point of action. Point of action means that point where force is applied, vector F2. So vector OB cross vector F2. Again this OB is perpendicular to F2 and sin 90 is 1. So we can write tau equal to minus F into OB, because F1 and F2 they are equal in magnitude. Therefore, here in place of F1 we can write F. Here also in place of F2 we can write F, because their magnitudes are same. But why negative here? Because this F2 produces rotation in clockwise direction, and clockwise moment of couple or clockwise rotation. In that case, moment of couple is taken as negative. So this is clockwise rotation. That's why it is taken as negative. Therefore, total torque about O is sum of these two torques, tau 1 plus tau 2. Therefore, total torque is tau 1 plus tau 2. Now keep this value of tau 1, that is F into OA, and tau 2 is minus F into OB. So we get this next step. Now here F is common. So in bracket we get tau equal to F in bracket OA minus OB. Now this OA, total distance OA minus this OB, we get this BA. Therefore we get F into BA. But this BA is perpendicular distance between these two forces, which is equal to R here. Therefore we can write torque equal to F into R. Remember this equation. So moment of couple of this body about this axis of rotation passing through this point O is F into R, and this is moment of couple due to these two forces F1 and F2 acting at point A and B respectively. Now we will find moment of couple of the same moment of couple of the same body due to same forces but about different axis of rotation. म्हणजे या ठिकाणी आपल्याला काय मिळालं RF टोटल इफेक्ट काय झाला तर अँटी क्लॉकवाईज डायरेक्शनला ही बॉडी फिरणार आहे, कारण हे इकडचं टॉर्क जास्त आहे अँटी क्लॉकवाईजचं आणि हे क्लॉकवाईजचं कमी आहे. म्हणजे टोटल इफेक्ट काय होईल तर ही अँटी क्लॉकवाईज डायरेक्शनला फिरणार आहे. सपोज दिस इज इक्वेशन नंबर 1. नाउ सपोज द सेम बॉडी rotates about different axis of rotation due to same forces acting at same points. तेच फोर्सेस आहेत ए आणि बी त्याच पॉइंटला ऍक्ट होत आहेत, परंतु आता ओ च्या जागी आपण दुसरा घेऊ ऍक्सिस ऑफ रोटेशन. मोमेंट ऑफ कपल अबाउट पॉइंट सी. सपोज ऍक्सिस ऑफ रोटेशन passes through point C now. Therefore, moment of couple about C due to F1, due to this force F1 will be given by the formula tau 1 equal to vector CA. We have to take this distance now because axis of rotation is passing through point A and F1 is acting at A. Axis of rotation is passing through point C and F1 is acting at point A. So we have to take this distance CA, vector CA, because we are taking this in vector form, cross vector F1. Similarly, here we in scalar form we can write tau 1 equal to F, magnitude of this vector F1, into CA. CA means this length, and this will produce anti-clockwise rotation. So this is taken as positive. Due to this force, this body will rotate in anti-clockwise direction about this point C. Moment of couple about C due to F2. Now again the axis of rotation passes through the same point C, but now this force will try to rotate that body, and this force F2 will again try to rotate this body in same anti-clockwise direction. So moment of couple due to this force F2 will be also positive, because anti-clockwise moment of couple is taken as positive. Here we can write tau 2 equal to CB, vector CB, because axis of rotation passes through this point C and this force F2 is acting at point B. So we have to take this distance, this vector, position vector of B with respect to point C, that is vector CB, cross vector F2. In scalar form we can write tau 2 equal to F into CB, because magnitude of F1 and F2 they are same, and that is equal to F. So here in place of F2 we have written F, and this CB we are writing in scalar form, so don't draw arrow over this CB here. And this also produces that rotational motion in anti-clockwise direction, so that is also taken as positive. Total moment of couple about O is given by tau equal to tau 1 plus tau 2. Keep these values of tau 1 and tau 2. This tau 1 equal to F into CA plus this tau 2 equal to F into CB. You can take F common in bracket CA plus CB. but this CA plus CB means total distance BA. Therefore, we get tau equal to F into BA. But this BA is R, small r. See this figure. Therefore, F into R. Therefore, torque equal to R into F anti-clockwise direction. हे जे टॉर्क आहे ते अँटी क्लॉकवाईज फिरवणार आहे किंवा हे जे मोमेंट ऑफ कपल आहे ते बॉडीला अँटी क्लॉकवाईज फिरवणार आहे. दिस इज इक्वेशन 2. मगाशी आपण इक्वेशन 1 पाहिलं होतं जेव्हा हे दोन फोर्सेस त्या बॉडीला ओ ह्या ॲक्सिस भोवती रोटेट करतात तेव्हा आपल्याला हाच फॉर्म्युला आला होता आणि अँटी क्लॉकवाईजच होतं. आता आपण ॲक्सिस ऑफ रोटेशन ओच्या जागी सी घेतला तेव्हा सुद्धा तोच फॉर्म्युला आलेला आहे आणि मोमेंट ऑफ कपल पुन्हा अँटी क्लॉकवाईजच आहे. म्हणजे याचा अर्थ ॲक्सिस ऑफ रोटेशन कोणताही घेतला तरी फॉर्म्युला आपल्याला तोच मिळतो. फ्रॉम इक्वेशन 1 अँड इक्वेशन 2 वी कॅन से दॅट मोमेंट ऑफ कपल अबाउट एनी पॉईंट इन इट्स प्लेन इज कॉन्स्टंट, दॅट इज इट इज इंडिपेंडंट ऑफ द ॲक्सिस ऑफ रोटेशन. म्हणजे ॲक्सिस ऑफ रोटेशन तुम्ही ओ मधून पाठवा, सी मधून असू द्या, ए मधून असू द्या किंवा बी मधून कुठूनही जाऊ द्या, तुम्हाला तोच फॉर्म्युला मिळालेला आहे. मोमेंट ऑफ कपल काढताना आपण इथे दोनच ॲक्सिस ऑफ रोटेशन विचारात घेतलेले आहेत. एक ओ मधून पास होतो आणि दुसरा सी मधून, आणि त्यांचे आपण मोमेंट ऑफ कपलचे फॉर्म्युला डिराईव्ह केले बघा इक्वेशन 2 प्रमाणे. आपल्याला दोन्ही ॲक्सिससाठी सेम फॉर्म्युला मिळालेला आहे. तुम्ही अजून तिसरा ॲक्सिस विचारात घेऊ शकता जो समजा पॉईंट बी मधून पास होईल आणि तुम्ही फॉर्म्युला काढा टोटल टॉर्कचा, तुम्हाला अशाच पद्धतीने असाच फॉर्म्युला मिळेल. अजून चौथा ॲक्सिस ऑफ रोटेशन तुम्ही घेऊ शकता जो ए मधून पास होईल आणि मग F1 मुळे ए भोवती काय मोमेंट ऑफ इनर्शिया आणि F2 मुळे ए भोवती काय मोमेंट ऑफ इनर्शिया, दोघांचं टोटल काढलं तर तुम्हाला परत हाच फॉर्म्युला मिळणार आहे. म्हणजे याच्यावरून सिद्ध होतं की ॲक्सिस ऑफ रोटेशन कुठेही असू द्या, मोमेंट ऑफ कपलचा फॉर्म्युला जो असतो तो सेम असतो. तो फक्त त्या दोघांमधलं डिस्टन्स हे आर आणि दोनपैकी एका फोर्सची मॅग्निट्यूड त्याच्यावर डिपेंड आहे. जोपर्यंत ती मॅग्निट्यूड किंवा ह्या दोन ॲक्सिसमधलं डिस्टन्स तुम्ही बदलत नाही तोपर्यंत ॲक्सिस ऑफ रोटेशन कोणत्याही पॉईंटमधून जाऊ द्या, मोमेंट ऑफ कपल बदलणार नाही. तर अशा पद्धतीने विद्यार्थी मित्रांनो आज आपण मोमेंट ऑफ कपल ह्या एका महत्त्वाच्या कन्सेप्टबद्दल शिकलेलो आहोत. थँक्यू फॉर वॉचिंग द व्हिडिओ.